send the key to this one. ใครจะพิมพ์ชื่อหรือไม่พิมพ์ชื่อก็ได้นะครับ แต่ว่าก็เรียกดูกล้องทีละคนเหมือนเดิมครับ604ผมไม่ดูกล้องตลอดครับเฉพาะเช็คชื่อแล้วก็จบกันแค่นั้นครับแต่ว่าคุณจะอยู่บน Meet แล้วคุณจะมีคำถามอะไรไม่เสียไม่อะไรแจ้งผมได้ตลอดนะครับพิมพ์ไว้ก็ได้ครับจะได้เป็นหลักฐานใน Meet นะครับส่วนการเช็คชื่อจริงๆก็ใช้เรียกฐานอย่างนี้นะครับซึ่งเสียเวลาเนาะแทนที่เราจะได้เรียนนะครับแต่ละ call set เพื่อมอนิเตอร์ทุกสิ่งทุกอย่างนะครับโอเค I hope that you can hear me right. Excellent connection. The good thing for M605 is that everything has been set up quite well. You don't need to get the bad quality at the beginning as in M604. That's a little bit worse than this. Okay, I need to open the file from class attendance.เครื่องเขาช้านะครับอันนี้นี่เครื่องเก่าครับที่อยู่ที่มีดนะครับเนื่องจากว่ารับ OBS ไม่ได้ผมก็ต้องใช้เครื่องนี้สตรีมไปที่มีดนะครับโอเคI need to share the monitor to you right YouTube นิ่งเลยครับ excellent condition เลยผมไม่รู้ว่าเกิดอะไรขึ้นครับพอมันเซตได้แล้วมันก็ excellent condition จะไม่มีดีเลย์อะไรเลยโอเค we are at the class attendance file right we are going to see whether you appear in the classroom or not and as what ทำไมจอไม่แชร์yes it might take a while นะครับถ้าใครจะลานะครับโปรดส่งก่อนนะครับไม่งั้นมันจะเกิดการสับสนตอนที่เช็คนะครับแล้วรู้สึกว่าเกิดการสับสนจริงๆด้วยนะครับเห็นไหมครับลาไม่ลาคราวที่แล้วนะครับ604เวลาลาเขาส่งก่อนเลยครับ I'm not sure why the monitor doesn't appear คุณเห็นจอไหมครับเห็นจอไหมครับthis one I in the YouTube I need to okayจอไม่ไปแล้วเอาใหม่ก็ได้โอเคเกณฑ์ entire screen 604จบเรื่อง Bristol Law นะครับก็สั่งการบ้านไปแล้วนะครับสำหรับเสาร์อาทิตย์นี้no สำหรับอาทิตย์หน้าครับส่งวันศุกร์หน้านะครับคุณก็เช่นเดียวกันนะน่าจะจบ Bristol Law I don't understand why the monitor cannot be shown โปรดตอบนิดนึงนะครับคุณเห็นเขาเรียกว่าอะไรนะมอนิเตอร์ไหมครับผมแชร์ไปครับผมงงว่าทำไมมันไม่ขึ้นให้คุณขึ้นไหมเอ่ย Can you see the monitor the class attendance file เห็นไหมครับ
ไม่เห็นครับไม่เห็น
ผมงงว่าทำไมมันไม่ขึ้นทำไมอีกรอบนึง entire screen this one หรือผมต้องเข้าใหม่ What happened but in the YouTube monitor you can see that okay now it comes okay that's great โหช้ามากเครื่องนี้นะครับผมคงไม่กล้ารันแล้ว okay the first person let me see you กรครับกรเงินบำรุงนะครับwhere is that กรอยู่คนไหนครับขอดูภาพนิดนึงในสิ่งที่น่ารักของ605คือคุณเปิดกล้องรอเลยไม่เหมือน604ผมยังไม่เห็นกรนะครับอยู่นี่ครับ where is that อยู่ไหนครับกรกำลังเลื่อนดูอยู่นี่กรเห็นแล้วกรช่วยเปิดกล้องให้ผมเห็นหน่อยได้ไหมเห็นไหมผม stop screen แล้วกันนะครับแต่คุณเห็นไฟล์ใช่ไหมครับว่าผมกำลังเช็คโดยใช้อันนี้นะครับคือพอเปิดไฟล์ใหญ่แล้วมันก็ไม่เห็นคุณก่อนอยู่ตรงไหนครับโอเคเห็นแล้วครับก่อนโอเคไฟล์ present let's go to the second person
ครับมาครับ
ปานาทรครับปานาทร
ครับผม
ปานาก่อน raise the hand everything is fine with you ปานาทร I'm going okay ปานาทรบรรจงศิริ
เราครับ
okay you have the rainbow behind you right okay
ครับ
everything fine let's talk about the third person วชิรวิทย์ครับอยู่ตรงไหนเอ่ยวชิรวิทย์
อยู่นี่ครับ
วชิรวิทย์โอเคอยู่ที่นิวยอร์กเลยตึกสูงนะครับโอเคfourth person สุภวิทย์
อยู่นี่ครับ
สุภวิทย์fine everything is fine fifth one นัทวินครับ
ครับผมครับ
โอเคนัทวินกฤตภพ number 6 please
วัสดีครับ
โอเปิดนานๆครับให้ผมเห็นนานๆกริตาวิท
อ่า
โอเค น่าจะอยู่ที่ประเทศกรีซหรืออะไรสักอย่างนะครับกริตาพบไปแล้วต่อไปเซเว่นปาวิท
ครับอยู่ครับ
กริอะไรนะเดี๋ยวปาวิทให้ผมเห็นนานๆนิดนึงครับคุณแวบเดียว หรือว่าผมต้องดูที่นี่อ๋อเห็นได้แล้วปาวิทโอเค thank you very much มีลายน้ำอยู่ข้างหลังครับ คือสองตอนต้องดูว่าตรงไหนเห็นคุณชัดเจนโอเค the 8% ปีราทัศน์ครับปีราทัศน์หรือปีราทัศน์นะครับ
ครับผม
ปีราทัศน์โอเคใช่อยู่ที่วิวสวยเลยน่าจะกระบี่หรือที่ไหนสักอย่างครับโอเคหน้าเมื่อนายกฎชวงวัดครับ
ครับ
กฎชวงวัดอันนี้เห็นแต่ตากับผมคุณครับ
เป็นไหมครับอาจารย์
ขอเห็นหน้านิดหนึ่งโอเคโอเค fine กฎชวงวัดต่อไปนัมเบอร์10ปาวัดครับปาวัด number 10
มาที่ตรงไหนครับ
โอเคอยู่ม้านะครับม้าข้างหลังnumber 11 which please 11 which อยู่ให้เลย
ครับ
โอเค fine 12ธนกร
มาค่ะ
ธนกรโอเค fine and 13ปาฏิหาริย์ครับ
สวัสดีครับ
โอเคครับโอ้อยู่ Galaxy หรือ Deep Space เลยนะครับ14 ธนทร please
มาครับ มาครับ เห็นไหมครับ
คนเดียวกันหรือเปล่าทำไมคล้ายๆกันเลยมุมกล้องธนทรจริงด้วยโอเค15 กิตติวัฒน์ let me see you please กิตติวัฒน์โอ้โหอยู่ที่หนังสือเพียบเลยครับกิตติ16 ทิรุตหอมชื่น
พี่ดุลามาครับ
โอเค fine พฤตินันท์17
มาครับ มาครับอยู่เนี่ย
โอเคครับ and let's go to the 18 ปานทัศน์ครับ
มาครับ มาครับ มาครับ
โอเค fine ผมก็ไม่เคยพบคุณตัวเป็นๆก่อนสักครั้งนะครับ จะได้จำว่าคุณคือใครจริง คุณให้ผมเห็นผ่านกล้องผมก็ไม่รู้ว่าตัวคุณจริงหรือเปล่าหรือรุ่นพี่รุ่นน้องครับ แต่คาดว่าน่าจะใช่ คงไม่มีน้องชายหรือพี่ชายมาเรียนเพราะวิชาฟิสิกส์มันค่อนข้างหนักสมองนิดหนึ่งครับ19 นนทกร please
มาครับสวัสดีครับ
โอเค20 วรินทร์ are you there ทำไมวรินทร์เห็นแล้วครับโอเคใส่หูฟัง21 รวินพลครับรวินพลน่าจะเสียงได้ถูกต้องนะครับโอเค fine โอเคครับ it's fine 22 วารินหรือวาริน
อยู่นี่ครับ
เห็นแต่ผมนะครับ
ครับผม เครื่องรอก่อนครับต้องชาร์จแบต
โอเค no problem 23 พระสิทธิ์ครับ
ครับมาครับ
โอเค fine thank you สวัสดีครับeverything is fine right nobody has problem ขอเรียนคุณครับว่าคนที่ลาไปเตรียมสอบ IELTS นะครับ คือปรึกษาทั้งสองครูโคแล้วนะครับ เขาบอกว่าไม่อยากให้นะครับ ก็ถือว่าเป็นขาดนะครับ คือถ้าสอบลาไปสอบได้
อาจารย์ครับแต่ว่าการสอบครั้งนี้เป็นการสอบที่โรงเรียนจัดให้ครับผมซึ่ง อยู่ในความดูแลของดร.โชคนะครับ
อ้าวเหรอครับ
ดร.ไม่ครับผมในการสอบของ EPAS ครับ การสอบของ EPAS ครับไม่ได้ไปสมัครสอบกันเองครับโรงเรียนควบคุม
อ๋อ คือโรงเรียนจัดให้ก็ตามแต่ว่า คือถ้าเวลาสอบอะได้ แต่ว่าเวลาเตรียมนี่มันต้องด้วยเหรอ ผมไม่เข้าใจนะครับ
อาจารย์ลองไปศึกษา
เคยไปสอบมาอยู่ต้องทบทวนนิดนึงอะครับตอนสอบ
โอเค แล้วว่ากันครับ เดี๋ยวผมเรียกว่าอะไร ผมทำไฟล์ class attendance score นะครับ ว่าจะเป็น0หรือ1ครับ0ก็คือขาดเรียนนะครับ แล้วก็1ก็คือเข้าเรียนเต็มแต่ถ้าลาเตรียมอย่างนี้อาจจะ ปกติจะมี0และ1นะครับ เข้าเรียนที่ผมทำมาทั้งหมดครับสำหรับมหาวิทยาลัยก็ตาม อาจจะเป็น 0.5 แล้วกันนะ เพราะว่าครูโคทั้งสองท่านเขาก็บอกว่าเขาให้ขาดถ้าอย่างเงี้ยครับ มันไม่ใช่เวลาที่คุณไปสอบจริง ๆ แต่ว่าผมครึ่งแล้วกันครับ กลางทางนะครับ ไม่อยากเข้มงวดเกินไปโอเคมากโอเคso we need to start our story which is something about snail's law, right? Oh, I didn't send you the link of the YouTube, right? โอเคเดี๋ยวผมหาลิงก์ YouTube ให้ก่อน ลืมไปเลยนะครับ ยังไม่ได้ดูไลน์ของห้อง605เลยโอเคแล้วไลฟ์สตรีมcopy ไลน์ M605 right this one โอเคนะครับถ้าใครอยากดูภาพชัดนะครับก็มาที่ YouTube นะครับ เพราะว่าเช็คชื่อแล้วนะครับผมไม่ค่อยสังเกตนะครับสังที่ว่าคุณปรากฏที่กล่องคือผมถือว่าทำทีเดียวพอละนะครับในการเช็คชื่อครับโอเค let's go to our storyผมอาจจะไม่ได้เรียกว่าอะไรไม่ได้เปิดฟังหูอย่างนี้ตลอดเวลานะครับระหว่างที่สอนนะครับเพราะว่ามันไม่สะดวกครับดังนั้นถ้าคุณมีอะไรแจ้งครับแจ้งด่วนทางมีดก็ได้นะครับทางไลน์โทรทางไลน์ก็ได้นะครับโอเคไหมทางไหนก็ได้นะครับที่แจ้งผมด่วนครับไม่ได้ยินไม่แตกไม่บึ้มหรืออะไรก็แล้วก็ตามนะครับโอเคplease let me go to the toilet for a while due to drinking too much coffee Okay. The voice is all right, right? Let me check the okay, fine. So we need to see the lecture notes, right? ครับที่พิมพ์มาก็นะครับถ้าไฟล์ไม่ตรงไงครับคุณก็ใช้หลักฐานงานนั้นมาแจ้งผมครับบางทีผมก็ผิดพลาดนะเพราะมันต้องคุมหลายอย่างมากนะครับคุมทั้งกล้องนะครับทั้งไมโครโฟนนะครับเพราะโควิดอย่างเดียวครับทำให้เกิดปัญหามากมายครับ we are talking about we are now I don't understand why the lecture note doesn't go to you Google Meet นะครับมักมีปัญหาไม่ทราบว่าเป็นเพราะอะไร Okay. Yes, I'm presenting, but the lecture notes doesn't appear. Huh? มันไม่ปรากฏไม่ขึ้นนะครับหรือว่าผมออกแล้วเข้าใหม่โอเค does it go ไปไหมครับแต่ YouTube เนี่ยมารอแล้วนะครับ lecture notes sorry ปิดอะไรที่ไม่จำเป็นก่อนดีกว่าclose this okay ไปไหมครับยังไม่ไปนะครับ I don't understand เดี๋ยวผมขอเดี๋ยวผมขอออกแล้วเข้าใหม่ดีกว่าครับเพราะว่ามันต้องสลับจอบ่อยๆนะครับ moment okay close anything that is not in use and this one is yes join now ผมเข้าใจนะครับถ้าคุณเปิดกล้องด้วยนะครับบางทีมันจะกินแบนด์วิดต์ของอินเทอร์เน็ตนะครับจะทำให้คุณรับชมภาพไม่ค่อยชัดด้วยนะครับ Oh no I didn't turn on the microphone multi-screen. Okay, in M605 last time I was a little bit late, right? Because I would like to finish the snail's law. Okay, but at the end we didn't. We almost reached the okay, that's fine. Okay, that's fine. All right. Okay. We're on page 80, right? It's not our case. We need to complete the snail's law on page 75. No. 75. Yeah, okay. Previously, we get this ratio, right? VA by VB equals NB by NA, and from the basic relationship at the beginning of this topic, there is a relationship between the psi of the reflecting component divided by the psi sinusoid function of the incident angle of theta A will be equal to the ratio of velocity of the light or the electromagnetic wave in the second substance divided by the velocity of the light or electromagnetic wave in the first substance. That's denoted by A and B respectively. And of course, we need to get back to the whiteboard. Okay. The camera, right? The camera is this one. Hello 1 2 3 โอเคที่ YouTube นะครับได้ยินนะครับว่าผมเปลี่ยนไมค์นะครับเป็นไวเลสนะครับเขาต้องเดินโอเค in Google Meet I need to stop presenting. Okay, and change the microphone as well. Set the audio. Okay, if you have a problem in receiving the voice, okay, the audio, just let me know. If not, we will go ahead with the snail's law. Okay, in M604 they have finished the first example of the light propagation during the daytime already. Okay, again, let's remind ourselves our story, the propagation of the light, which is a kind of electromagnetic wave, okay, which is only one band of the electromagnetic wave. It propagates from the first matter or first substance, and we have two substances, right? The second substance or the second matter, and there is the boundary. There is a boundary between both substances, and the incoming angle is called incident angle. Okay, it's theta A. Okay, and This one is theta r but we have มีปัญหาเรื่องเสียงอะไรไหมครับโปรดแจ้งได้เลยนะครับthis is theta r and this is theta b okay which is the reflecting angle in the second component in the second substance which is called substance b let's say and we just what we got previously is the relationship velocity of in the first substance A divided by the velocity or speed in the second substance equals okay the opposite sorry it's NB okay NB divided by NA and another relations from the beginning is the ratio between the incoming or sorry the reflecting angle the sinus the sine function of the reflecting angle divided by the sine of the incoming or incident angle which is theta A equals velocity the B and velocity or speed in the first substance and after you replace the right hand side of this one by this equality what you get will be A right and it's going to be psi again on the left hand side everything remains the same psi of theta A equals this one okay it has the same relationship okay B above A below but after we replace this ratio by the indices of reflection what we are going to have will be something different in the opposite way okay it will be NA by NB right and oh sorry if you don't want the ratio expression you can move one term to another side so that it becomes on both sides we are going to get on both sides we are going to get the product of that what happens why don't you see me on the whiteboard you can see me on the whiteboard right ทุกคนที่มีดนะครับเห็นผมที่กระดานไหมครับเห็นผมที่กระดานไหมเอ่ยเพราะว่าตอนนี้พูดที่กระดานนะครับwhat happens เห็นนะครับโอเคไหมที่มีนะครับผมอยู่ที่กระดานนะเพราะว่าตัวนี้มอนิเตอร์ผมมันไม่ขึ้นรูปกระดานผมก็งงว่าเอ๊ะสัญญาณกระดานผมหายหรือเปล่านะครับส่วนที่ YouTube ไม่น่ามีปัญหาโอเค we are going to move we don't want the ratio expression we are going to move the index of reflection for the second substance to the left hand side we move the sine of theta A okay the angle the incident angle to the right hand side and what you get will be sine theta B and times NB right you move NB to the left hand side and you move side theta A to the right hand side your right hand side is going to be NA times sine theta A right and it's not so nice okay it's not in the order so we just leave everything in a sequence okay in terms of alphabet sequence like this NA sine sine theta A okay the index of refraction in the first substance times the sine function of the incident angle, okay, theta A, equals the index of refraction in the second substance times psi of the angle in the second substance, which is theta B. Okay, now everything is in order, okay, A and B, and in both at both sides we have the product of index of refraction and the psi function of the angle at each substance. Okay, and this one, okay, is known as the discovery by Willenbrod Snellius. Okay, it's simply called Snell's law. Okay, it's called Snell's law, and that's it for this expression. Okay, that's the Snell's law. You may have ever seen this expression before. Okay, and let's get back to the lecture notes. Let's get back to the lecture notes. It's better to change the microphone. Okay, now present entire screen. This one. So now we go ahead on the page 76. Okay, we have already passed the Snell's law, right? And in this figure, okay, it's it's spatial for us because we are studying some behavior of the light propagation in two substances. In our main interest, okay, our main interest is the polarization. Okay, how the lights arrange their electric field orientation. Okay, that's our main interest. Okay, let's take a look at this figure. This is the incoming light. Okay, what is the symbol of the magenta arrows here? What is the meaning of this one? Okay, this is the light that we have seen earlier. Okay, it has different directions of the electric fields. Okay, and it means the light can have any possible direction of the electric field. Okay, there is no a certain direction or orientation of the electric field. So we call this one the light like this as the unpolarized light. Okay, because this light has many directions or many orientations of the electric field. Okay, it's not tidy. Okay, the electric field orientation is not tidy, it's not in order for us. Okay, so this light just propagates to okay, let me tell you first. There is a first substance here. Okay, let's say it's substance A. Okay, and this substance has the index of refraction, which is denoted by the variable n with subscript A. Okay, of course, is what we have seen before. It's the index of refraction, which is the ratio between the the light speed in the vacuum divided by the light speed in such material, in that material. In these lights just propagate in straight line like this. Okay, there will be a source of the light like this. Okay, when we consider only a narrow beam, which can be treated as a straight line like this. Okay, and it just hits the boundary between the first substance, and let's talk about this substance. This is the second substance. This figure is shown in 3D, okay, three-dimensional space, okay, 3D view, let's say. And the second material is called material B, and it has its own index of refraction, which is n with subscript B, okay. It depends on each situation, whether it's water, it's glass, or it's any kind of liquid or metal or solid, okay. And of course, this one will hit the boundary, okay. Let's say the boundary of these two materials is smooth, okay. The boundary surface here is smooth for simplicity, okay. If we don't consider the smooth surface, we would not get easy problem to analyze, okay. And at this point, okay, the light is going to have reflection like this, okay. It propagates from the heating point to this direction. And as you know, from the second law in geometrical, where is my arrow in? Okay. You know, from the second law in the geometrical optics, the principle of the geometrical optics, there will be reflection component, right? Reflecting components, and the angle here, which is called reflecting angle, will be the same as the incident or incoming angle. So actually, this is theta A, right? Theta A, because this is the angle in the matter A or the substance A, right? But okay, we will not talk about theta P. Theta P will come later. This is theta A. This is theta A, right? At the incident or input component, and there will be first the reflecting component. Okay, it has propagation in this direction, and this angle is going to be denoted by theta R, okay, which represent the reflection or reflecting component, okay. But what we know earlier from the second law in the principle of geometrical optics, it says that the incident angle will be the same as the reflecting angle. Okay, that's the second law in the geometrical principles. But let's talk about the second component that can happen. The light can propagate through the second material, which is material B, okay, in this direction. The dashed line means it's not easily visible, okay, because this one is inside the material B, but this one can be seen, okay. It's directly in the second material. This angle should be theta B, okay, because it's the angle measured in the B side, okay, the material B side. And that's the normal situation. But what the physicists have observed is the following. If you let the light propagate with the angle with a certain or spatial value of angle, okay, if your incident angle has a spatial value, the reflecting light will have the E field orientation like this. Okay, let's consider first the reflecting component. The E field, the electric field orientation will be parallel to, I forgot to mention. Okay, in the first law of the principle of the geometrical optics, the four lines, okay, the incident ray, the reflecting ray, okay, the reflecting light, okay, reflecting ray here, the second line, and the third line, which is reflecting ray, okay, reflecting ray. The fourth line, which is the normal line here, normal, okay, will all lie in the same plane, as you know in the first law or first rule in the principle of the geometrical, okay, and that plane is called plane of incidence, okay, which is denoted by the yellow plane here, okay, it's a smooth surface, okay, and there will be another surface, okay, another plane which is also smooth. That one is called reflecting surface. Okay, the E field orientation for the reflecting components, the reflecting ray, will be parallel to the reflecting surface. Okay, this is the plane of reflecting surface, and here is the E field, electric field orientation, which is the side for orientation for the E field polarization observation. Okay, we will consider the polarization of the lights by taking a look at how the E field is oriented, right? Which is this one. Okay, the E field is parallel to the surface. Okay, this will happen only when you let the light propagate with a spatial angle, okay, and that spatial angle is called theta p, okay, it's called polarizing angle, okay. If you let the light propagate in a different value other than this, okay, you will not get this single orientation of the E field, okay, you won't get that if you let the light propagate with different or other values of the incident angle, incident ray, okay. But if you let the light propagate with spatial angle, you will get the E field orientation like this, okay. It's parallel to the reflecting surface, okay. As you know earlier, if the light has a single orientation of the E field like this, we are going to call this light as the light with linear polarization, okay. If we have a single orientation of the E field, we would say that light has a single it has a linear polarization. Let's take a look, let's talk about the second output component, which is the reflecting ray, okay. It propagates through the second material, okay. Of course, we know that there will be an angle, which is the angle measured also from the normal line. It's called theta b. But if you let the light propagates with a spatial value, which is called a polarizing angle theta p, these components, the reflecting components, will have only two orientations of the E field. What I forgot to mention to you is that the reflecting components, the reflecting light, will have less intensity than the incoming light, okay, the incident ray, okay. The intensity here will be less than the intensity at the input side. You know why? Because only some lights only some amount of light will be reflected, okay, from the atom of the second material, okay, but part of them can propagate through the atoms or molecules of the second material, and that component is the reflecting light will have also spatial behavior, okay. In this reflecting light, it's going to have only two orientation, okay. The first orientation of the E field will be the same as the reflecting one, okay. And this component, the E field here, okay, will be also parallel to the surface, the reflecting surface, okay, or surface of reflection, okay. This E field, okay, this E field will be parallel to the reflecting surface, and there will be another orientation of the E field, okay, which is 90 degree, okay, perpendicular to the former orientation of the E field, okay. And the light in the second component is strong, okay, and we would not say it's fully polarized, okay. It's not completely polarized because it has two orientation of the E fields, so we would say slightly polarized, okay, or we would say slight polarization, okay. But the intensity of the light here is stronger than the one above in the reflecting component, okay. And that's happen when you let the light propagate with a spatial value of the incident angle, okay. If not these properties, the orientation of the E field in both components will not hold at all, okay. Let's move to the next page, and this is what I have explained it already. And here is the 2D view. Oh, I'm sorry for that. ขออภัยครับผมขออนุญาตเข้าห้องน้ำอีกนิดนึงครับ Okay, I'm back to the side view. Okay, side view of the scenes in the previous figure. This is the two-dimensional view. Okay, the side view of the previous figure. The previous figure is the one in 3D view. Okay, and I don't understand why this one doesn't go ahead at all. ผมงงว่า ทำไมอันนี้ไม่ไปนะครับ What happens? Okay. Meet. น่าจะหลุดนะครับอันนี้โอ้หลุดนะครับอันนี้ขออนุญาตมอนิเตอร์นิดนึงครับวิธีOkay, so that I can see what's going on in our lecture. Okay, thank you very much. Here we arrive at this figure, and we are going to get some formula, right? You have seen already the spatial type of the E-field orientation, okay, which is called polarization. Okay, and one more thing that the physicists have found is the following, which is the story for us to get some calculation. Of course, this is the incoming light, right? That has any possible direction of the E-field, right? And it just comes with the angle theta A. Okay, when you let the light propagate with a spatial value, it's called polarizing angle, which is denoted by theta P. There will be some spatial effects, as you have seen earlier. Okay, this is the notation of the E field. Okay, E field is parallel to this surface. Okay, which is reflecting surface. Okay, and this is the air. Okay, this is the first substance. Here is the second substance, and this is the reflecting components, reflecting ray, and the angle which is measured from the normal line is theta b. Okay, here in the reflecting ray, okay, there will be two orientations for the E field. Okay, the first one is the one which is parallel to the reflecting surface, okay, which is the same direction as in the reflecting component. Okay, this one has the same direction as the direction of the EDE field in the reflecting component, but there will be also another orientation of the E field. Okay, this one is 90 degree to the first orientation. Okay, that's what you have seen in the 3D views. That's why we need to see two types of figure. Okay, because it's quite difficult to see every structure in this phenomenon. The spatial thing that happens, the physicists have found is the following. When you let the light propagate with a spatial value of the angle, you will get the right angle, okay, which is 90 degree here. Okay, this 90 degree is in between the two output layers. Okay, 90 degrees will take place between the reflecting ray and the reflecting ray, okay, the ray in the first substance and the ray in the second substance, okay, you will get 90 degree. If you let the light propagate in the different value of the incident angle, you will not, okay, you will not get the right angle, the 90 degrees here, okay. And we are going to reach the, what time is it? Okay, we still have 27. Hope that we could we need to go to the whiteboard, and I will derive the Brewster law to you. Okay, we move to the whiteboard, and we need to change also the microphone. Okay, and as okay here in the as you know, this is the incident ray. Okay, you have polarization angle. It actually theta A, okay, but if you let the light propagate with a spatial value of angle, which is theta P, is the audio file. You can hear me, right? I use the wireless microphone when I move to the whiteboard, okay, so that we will not lose the explanation. Okay, this is the output ray, okay, that's the reflecting ray. This is the reflecting ray, okay, reflecting, okay, reflecting ray, and this one has linear polarization, right? This one is this one has almost complete polarization. Okay, there are two orientation of the light, but it's not the main target for us right now. But another important thing is that the angle between the reflecting component and the reflecting ray will be 90 degree, okay, will be right angle. And what we have got before is the Snell's law, right? We are going to go ahead with the Snell's law by observing the line in by observing the total angle in a straight along the straight line. If we draw that figure clearly again, we know that this we are going to draw this line, right? This is the normal axis, normal line, we will say normal line, right? And this one is the reflecting component, okay, reflecting component, reflecting ray, okay, and this one is called refracting, okay, reflecting ray or reflected ray. What they say is this angle will be right angle if you let the light propagate with polarizing angle theta p. This one will be right angle, which is 90 degree, right? I hope that you can see it in the on the whiteboard, right? You can hear as well. Okay. But what we know previously is that this is the reflecting angle, which is the same, okay, which is the same value as the incident angle. And if we let the light propagate with theta p polarizing angle, this one should be also theta p. And this is the reflecting angle, okay, which is already in the B material. Okay, it's reflecting angle. Okay, it should be denoted by theta B, right? And you know that this is the normal is a straight line. Okay, a straight line. The angle for one side in one side of a straight line will remain 180 degrees, right? And we will use this relation. We can say that first, the first angle is theta p, right? Theta p plus, this is the first angle. This is the second angle, which is 90 degrees, right? 90 degrees. And the last one is theta b. Will remains 180 degrees. Okay, that's the normal, typical knowledge you get from the maybe in the primary school. Okay, we get theta p plus 90 degree plus theta b equals 180. We are going to find what exactly theta b is. So you just move theta p to the right hand side. You just move 90 degree to the right hand side, and what you get will be theta b will be 180 degrees minus the first one you move to the right is going to be negative, right? Theta p you move 90 degrees to the left to the right hand side is going to be minus or negative. Okay, and you know that 180 and 90, okay, the subtraction of these two numbers is going to be 90 degrees again, and minus theta p, right? And that's the first relationship we are going to use. Okay, in from the Snell's law. Okay, let's get back to the Snell's law. This is the result we have got recently. In we are going to substitute theta b, okay, into this formula. At this portion we have here theta b. Okay, theta b is over there. Okay, okay, now when we substitute this scenario into the Snell's law, we are going to get we are going to have let's apply the Snell's law to that phenomenon. We get NA, okay, and psi theta, the incoming, okay, the incoming angle is theta A. We can say that, but if we let the light propagate with a spatial value of the incident angle, let's say it's theta p, we would substitute theta A by theta p. Theta p, okay, equals this one is NB, right? Because we are considering the second substance, which is titled B, okay, and this one is side theta b, okay, because the refracting angle is theta b, and as we know, theta b it has the relation to theta p by 90 degree minus theta p, okay, because if you let the light propagate with a polarizing angle, you get 90 degree, okay, between those two rays. And here we need to substitute theta b from this equation, which is 90 degree minus theta p into this position. And you can see that you get psi okay, psi theta b will be actually psi 90 degree minus theta p, right? This one. But what you know before is the following. From your last 2 years or the last 1 year, you know the trigonometric identity psi of 90 degree of pi by 2 minus x, okay, will be equal to what is that? it remains cosine of x, right? And this is the one of the trigonometric identities that we need to know, okay? Especially when you are at the high school level. Here, now sine 90 degree minus x is equal to cosine x. And of course, for our scenario, we would get this one, okay? We will have cosine of theta p only, okay? We get everything in terms of theta p, okay? Because theta p is a miracle angle, we would say that, okay? Miracle angle. And now this term is actually cosine theta p. We will go ahead with the Snell's law to see what's going on further. Can I remove this? ผมขอลบอันนี้นะครับ Okay, but I will not leave this expression because it's still useful further. Okay, in the Snell's law, we have on the left hand side n a. I'm not sure whether it's too high or not. Okay, it's fine. n a times sine theta p. Okay, a miracle angle, polarizing angle, and equals nb, right? nb and sine theta b. But we will not leave sine theta b anymore because it's actually equals, it's actually cosine theta p. So we write down here cosine of the angle, polarizing angle theta p, okay? And you can observe that, you can see that we have the same angle theta p on both sides, okay? Is it possible to move everything so that theta p terms can stay together, and we move the remaining terms to another side, okay? What we can do is sine is here, cosine theta p is here. We move, you can move in both way, okay? The cosine to the left hand side, na to the right hand side. So you get on the left hand side sine theta p divided by cosine theta p equals, okay, nb on the right side stay at the numerator position, and we move na from the left hand side to the right hand side, it will stay at the denominator position. And what you know from trigonometric identity, what is that? This is this ratio. What is actually this ratio? What is the meaning of that? It's the tangent function, right? It's a tangent function. So we get tan, okay, tan theta p equals nb, okay, nb, index of refraction in the second material, in the B material, and index of refraction in the first substance or the first material. And that's it, okay? And we get this law, which is called Brewster's law. But what is the use? What is the benefit from this expression? This benefit, the benefits from this expression is the following. Okay, we can determine the angle, the miracle angle theta p, or the polarizing angle, by the ratio between nb, okay, the index of refraction in the second material to the index of refraction in the first material, which is okay. And how could we do that? We just use the inverse function, inverse trigonometric function, okay? You know that. Please, one thing I need to mention is the following. Please don't use this kind of thing as the inverse function, because you can have two different meaning. It means what this may be what you would like to find. Okay, it's arc sine x, but it can be interpreted as it's 1 by sine as well. Okay, and this one is actually cosecant. Okay, which is not what we want. Okay, we don't want a cosecant at all. So please avoid the use of inverse function like this. Okay, use only arc as the inverse function of the trigonometric functions. And as I mentioned before, as I mentioned earlier, and in that area, we will use this kind of notation, okay, to represent the inverse function arc10. Okay, we won't use the power of -1. Okay, it's simple to write, but it can bring us ambiguity. Okay, it may make us to get confused. Okay, and this is tan theta p. It may make us confused. Okay, and on the right hand side you get also the arc10. Okay, arc10 of NB by A and here, and on the left hand side, okay, the inverse function will cancel the normal function, and what you get will be theta p, okay, equals arc10 n NB by NA. Okay, and this is what we need to be able to remember. Okay, it's called this one is called Brewster law. Okay, it's Brewster law. Okay, Snell law is what you have seen earlier. Okay, this is Snell law, but this one is Brewster law, which is which is useful for us in this topic. Oh, we still have 10 minutes, right? Okay, we move to the lecture notes. We go to the lecture notes. Okay. Lecture notes. Entire screen. Okay, let's get back to the lecture notes. All right. ไปไหมครับ Google Meet ไปไหมเอ่ย Lecture Notes Google Meet ชอบ ไปช้า ไปไหมครับ Google โอเค ก็จะใช้เวลาหน่อยนะครับที่ Meet นะครับ โอเค we are here at the lecture notes, and we have just recently discovered a law, okay, which is called Brewster law, right? This one. Okay, this is the step during I delivered it to you, and the result is this one. Okay, this expression is called Brewster law. Okay, and I have shown the more complete version, which is the arc10 version expression of this one. Okay, arc10 expression of 21. Okay. Okay, the Brewster law says that if the light propagates, if the tangent of the incident angle is equal to the ratio between the two indices of the refraction, okay, you will get the reflected light, which is completely polarized. Okay, the reflecting components of the light will have linear polarization, okay, or completely polarized. Okay, it's the same meaning. Both both have the same meaning. Okay, let's go forward to the first example. Sunlight reflects off the smooth surface of an unoccupied swimming pool. Okay, what is the reason why we need to mention unoccupied swimming pool? Because if someone is swimming in the swimming pool, okay, there will be some fluctuation of the water surface. Okay, so the surface of the water surface will not be smooth. Okay, if the surface of the reflecting or if the surface of the reflection is not smooth, it's difficult for us to analyze or to calculate. Okay, you have to go above to bachelor degree or higher level to be able to compute that scenario. But for us in the high school level, we consider only the smooth surface case of the water in the swimming pool only. Okay, this is the light. Okay, the sunlight, which is a kind of electromagnetic wave. Okay, and let's the indices of reflection. Actually, it's not correct. This ตรงนี้ผิดนะครับต้องแก้เป็น reflection นะครับเดี๋ยวไปแก้ให้นะครับต้องเป็น RA นะครับตรงนี้ RA นะครับเดี๋ยวผมแก้ให้นะครับไม่ใช่ reflective นะครับ reflective okay of the air B in air equal 1 and reflecting index of the water is 1.33. If you don't understand this configuration, just take a look at the free body diagram here. Okay, this is the sunlight propagating to the boundary between the air. Okay, boundary between the air and the water. Okay, the water in the swimming pool. Okay, it doesn't matter whether how much you input. Okay, how much the chlorine inside the water. It doesn't matter. Let's say it has the index of reflection as 1.33. There will be two components, as we have said, reflecting component, okay, and reflecting components. Okay, of course, there will be incident angle on the left side and of the reflecting components on the right side, and there will be the third angle. There will be the third angle, which is called reflecting angle. Okay, reflecting angle. And let's get back to the question in this example. The first question is, at what angle of reflection is the light completely polarized? Okay, what does that mean? It means what is the value of reflecting angle here? Okay, and according to our second rule in the principle of geometrical optics, the reflecting angle will be the same as the incident angle. Okay, the incoming angle will be the same as the output angle. Okay, in terms of reflection. Okay, it doesn't mean theta p will be equal to this one. Oh, no. That's the first question. Okay, they would like to know what angle of the reflection will make the light here completely polarized. Okay, it means you will get the linear polarization of the light in this component. So let's get back to the whiteboard so that we can make the derivation. We have still 3 minutes. Stop presenting. Okay, in this one we get back to the whiteboard. We change the microphone. No. Okay. Okay, now we get back to the whiteboard. เหลือ3 นาทีนะครับผมต้องไปอย่างเร็วนะครับเพื่อว่าจะได้จบตัวอย่างนี้ก็รอ iPad นะครับถ้า iPad มาผมก็จะใช้เขาเรียกว่าอะไรใช้ Good Notes นะครับเขียนให้คุณเนาะตามที่คุณร้องขอนะครับก็คุณร้องขออะไรผมก็ทำให้คุณหมดนะครับOkay, they ask what value of the reflecting angle. Let's say the light will have linear polarization when the incoming angle, the incident angle will be equal to a miracle angle or spatial angle or polarizing angle, right? And from the second law in the principle of the geometrical optics, it says that the incident angle is equal to the reflecting angle. So this angle will be equal to this one. Okay. If we find this angle, it will be the same as the angle that the example asks us. So we use the Brewster law, which is theta p, right, equals arctan of. Okay. Please note that the Brewster's law says the ratio between the index of reflection in the destination side, okay, the second side divided by the index of reflection at the first side, okay, so it's NB by NA, okay, and what we know, the first substance is the air, okay, NA is N index of reflection of the air, okay, which is 1.0. And NB, okay, the destination side, the second substance is the index of the reflection, index of reflection for the water, okay, and probably just say it's 1.33, okay, and if we substitute this value into that expression, it's arctan of theta water divided by theta air. Oh, sorry, it's N air, N water and N air. So this one is arctan. And water is 1.33. Okay, divided by 1.00. So you use the calculator. Okay. You need to have electronic calculator like this, or you just put it in any website. You will get the value, which is 53 degrees. Okay, and that's it. This the answer for the first question. And the second question in this example is that they ask us about what is the value of the reflecting component. Okay, ผมไม่กลับไปที่เลคเชอร์โน้ตนะเพราะมันจะเสียเวลาเราจะหมดเวลาแล้วจริงหมดแล้วเลยเป็น1 นาทีแล้วนะครับ What is the value of theta b? So as we have got before, theta b has the relation to the polarizing angle by this expression, right? 90 degree minus theta p. Okay, if you know theta p, you will get the reflecting angle, which is theta b. Okay, theta b is the angle at the second substance, okay, the material B. But we just have got, we have recently got the polarizing angle here, or reflecting angle, okay. We can determine also the angle in the second substance, which is 90 degrees minus 53 degrees, okay. It's equal to 37 degrees, and that's it for the second question in this example. นั่นก็คือทั้งหมดนะครับสำหรับเลคเชอร์วันนี้นะครับแต่ว่าผมขอสั่งการบ้านนิดนึงนะครับส่งวันศุกร์หน้านะครับเพื่อว่าคุณจะทบทวนนะครับโอเคไหมว่าคุณจะได้ทบทวนส่งวันศุกร์หน้านะครับการบ้าน1 ข้อนะครับปัญหาก็คือให้ไปนะครับ ให้ไปหาโจทย์ใดๆก็ได้นะครับโจทย์ใดๆก็ได้ที่เกี่ยวข้องกับเรื่องของ Brewster Law โอเคไหมครับไม่เอาเรื่อง Snell's Law นะครับ Snell's Law คือสิ่งที่คุณเรียนมาแล้วในม.4 หรือม.5 นะครับอันนี้ผมแค่มาทวนแบบละเอียดให้คุณอีกรอบนึงครับเดี๋ยวอยู่ดีผมขึ้น Brewster Law มาไม่รู้ที่มาที่ไปนะเพราะว่าผมไม่ได้สอนคุณมาตั้งแต่ม.4 ม.5 นะครับ so the homework is for the next week okay the submission time is next Friday okay you have 1 week just find any problem that has the relation to the Brewster formula okay use the Brewster formula this one equation 21 โอเคการบ้านนะครับหาโจทย์ใดๆก็ได้นะครับที่เกี่ยวข้องกับการเดินทางของ electromagnetic wave จะไม่เป็นแสงไลท์ก็ได้นะครับแต่ขอให้มี2 substance นะครับ2 material นะครับแล้วคุณก็ไปหา index of refraction นะครับบนตารางก่อนหน้านี้ก็ได้นะครับใช้ค่าจากตารางก่อนหน้านี้ที่หน้า70หรือหน้า71ก็ได้นะครับจะมี index of refraction คุณไปเลือกเอา material อะไรก็ได้นะครับที่คุณชอบนะครับอย่าลอกกันนะครับอย่าใช้ค่าเดียวกันลอกเดียวกันค่าเดียวกันมีทำให้ผมเข้าใจว่าคุณลอกกันได้โอเคไหมครับ if you have any question just raise your hand and let me know I'm going to put the headphone so that I can hear what you may ask me I'm sorry for being late again มีคำถามอะไรไหมครับ if not we are going to quit our lectures today okay มีคำถามไหมครับไม่มีเราก็จบกันวันนี้เท่านี้นะครับ see you tomorrow afternoon right bye bye ครับสวัสดีครับ